Good. Good evening, everybody. So, this week's lesson 4. We're moving pretty long at a pretty good pace. Let me rebuttal a couple things from last week, the week before, and the week before that. The challenges. Use your username at the end of the URL. Check the announcements. Directions are there. We still have a couple people, about 6 people, using the same URL. That doesn't work. So, use your username. Last week, added logic to our code, added some decision-making capabilities, comparison operators, all kinds of good stuff. And then we went into while loops and for loops. So we took our logic and we made it repeatable. So we could do a lot of things. Say if you wanted to get all the file names and the directory they're in and list them all, if they're a directory or if they're all files, right? Of course, you could do that with Bash. You could do that with PowerShell. You could do that with a whole bunch of things. But what if you needed it inside of a Python program? Could you list the objects in a directory and say for each object in my directory, list the name and the full path and do a join and get the full absolute path for that object? And can you make it repeatable? So you could change what directory you wanted to look at, difference from someone's user folder or their downloads or desktop. The answer is you can. We'll do that at the end. It'd be really fun. But this week, learning how to create reusable code. One could argue that all our code has been reusable. Yeah, it is. Cut and paste it, change some variables, change some names, change some logic. You're good to go. This right here, though, is making your code, defining it, and then calling it. Then when you call it, it performs something for you, goes back dormant until you call it again. So it's reusable code within the same script. It's loaded in memory. Your functions are indeed types of objects that perform actions on objects. So that's the fun part, right? So these are just some notes. Then we're going to rip through these. The topic of functions shouldn't be scary or new. You've been using them all along. Type, integer, float, help, range, dir, print, all those are types of functions within Python. So it's something that takes an action on some objects, right? Think of it that way. They're reusable pieces of program, code scripts, a name block of statements, defined to as a name. And you name them very similar to variables. You could read pip 8, Python engineering proposal, pep 8, my bad, pep 8, and get better ideas on how to name them. Name them what they do. Name them what they perform, right? That'll make more sense the more we get into them. You also seen functions like max, min. Max, of course, will give you the max of whatever the value of the string is. And on an integer, it'll give you the max integer. Min will do the opposite, of course. Length function's a good one. Let's just run this. I'll just hit F5. Okay, cool. We'll save it. Oh, no, invalid syntax, because that is a comment. Like I said, this is more notes than anything. But here we have the basics of how we're going to operate and build a function or a function block, right? Use the key term def, which is short for defined function. Give it a name, open close parentheses if you do not have any arguments, a colon, a hard return and a tab over. Python loves its white space, right? So it's a lot like an if statement. It's a lot like a for loop or a while loop. And here's an example. Define, say hello, open close parentheses, colon, and of course, here's your script statement or script block of what you're actually going to perform. And it looks like that if you do it in a shell. Hit enter twice, get back to the prompts, and now you can do things like call on, say hello. Call on, say hello, open close parentheses, hit enter, and of course it prints hello class. Now you could do things like call on say hello, var1 equals, hit enter, hit sit, and now when you hit var1, there's nothing there. Well, why didn't that variable save the output from the function? Well, I'll tell you why. Your function didn't return anything. When you call in the function name and hit enter, when you execute the function, all it does is print to screen, hello class. So in order to get a function to be fruitful, we use the return function. We'll talk about that in a minute. But you can get to print all kinds of fun stuff. This is just a cheap way of showing that you can call on a function. We'll define a function called print lyrics, and then we'll define another function called repeat lyrics. And you'll notice that repeat lyrics calls on print lyrics twice. So if we run repeat lyrics calls on print lyrics twice, so we should get I'm a lumberjack and I'm okay printed twice. And that's exactly what happens. So functions could call on other functions. That's a huge thing to grasp. And when you design your code, like you could have a do you want to play a game function like start game, yes or no. And start game could call on the game function, which could be a part of your main function, which could also call on your scores function and all this fun stuff. So now if you have a good scores function in a game, you could take it and use it in another game. Like look at the guys who make Call of Duty or like any game that has like iterations of it. They used a lot of the base code. They just changed the feeling or changed certain things about it. Sometimes not even that much, right? That's a fun thing about functions. Now, the flow of execution. Right now, a lot of our scripts have been running top to bottom. When they hit a loop, they'll stay there for a minute, perform their loop function, and keep going top to bottom. Functions, you can get pretty wild with them. You can define functions all over the place, but where you call them matters. Say if I called on something called test 1, 2, open, close, I get an error that's not defined. I didn't define it yet. It's not in memory. You could run an ID on test 12, and there's no such thing. It's not in memory. Now, the minute I define test 1, 2 with no parameters, I'll say print, this is it, right? And now when I call on test 1, 2, it prints, this is it, and you can do an ID of it. And now I open, close a parameter, so it ran it, and it gave me the ID, the memory location of it. What happens if I didn't do the open, close parameter parentheses? There's just the new ID location of it, right? That's the ID of the function. You notice this should stay the same. And if I do this one, it should change. Or, since it's still a memory, to call on it. This is the output of the function with the function being ran in memory. And this is where the function resides in memory. Kind of cool. Sweet, right? Python, how it works under the hood is pretty slick. And we'll talk more about the flow of execution as you design some stuff. Some good tips here. Some folks are turning in files like text.py or py.py or parentheses 2, parentheses 4, py. You're going to be IT professionals. Be aware of the file extension you're using, and everything you turn in from now on should be a .py file. You know, I force you to name them a certain way. I force you to do the headers a certain way, use a template, and understand what a file extension is, because in real life, you need to. If you turn in a .text file to a lead programmer or a scripter or a lead cybersecurity expert or engineer like myself, and it wasn't the data file I needed, the type of file I needed in that moment, I'm going to be pretty upset. File extensions are pretty low level. You should know what they are by 200 level class. Most people in the class, you've been born with computers being on the planet. So understand what they are, use them, right? Especially in cybersecurity, you should pay real close attention to file extensions. You need to know what a lot of them are and how they perform and where malware likes to hide and where it doesn't, right? They matter. So just a side thing right there. But here we have something. Here we have a definition statement. We call our function print twice. We have something called the phrase. And then we have print the phrase twice. Well, this argument, when you define a function, this is an argument. And when you fill it in, it's a parameter, right? So define print twice the phrase, and then it'll print twice. So let's run this. Let's see what we mean by the phrase, right? So we can call on print twice, print underscore twice. My bad, low T. And now here we can say this is new. And when I close it and hit enter, it prints whatever I passed it as an argument twice. Cool, right? Can you pass the output of something to another function? Of course. We'll get to that in a second. I just want to. This is a fun function right here. So print max takes two parameters, A and B. When we fill A and B in with values, they become arguments. When you define them, they're parameters. So print max takes two parameters, A and B. It'll check if A is greater than B, perform something if it's true, right? So let's go ahead and rip this one. My bad, messed that up. So now we have print max, and we'll give it it takes two integers, so we'll do 10 and 12. And we have 12 as maximum. So is 10 greater than B or 12? False. Is it equal? No, 10 is not equal to 12. Then B is maximum. And that's exactly what we got. Handy dandy, right? Here we got some other things. We could pass it variables, X and Y. Here we define X and Y. We call them print max. Instead of using A or B, we just give it the value of X and the value of Y, and it performs as normal. I'll do that really quick so you can see the difference. And here we go. 7 is maximum. Works out just fine. So along with the def statement, you have a return, which is pretty cool. You could use it in multiple places if your logic is true or if your statement is met. Or you could return something all the time at the bottom. It's up to you. So you could return the value. Well, what does that mean? Well, the object that you returned from print max. So I'm just going to say this. So we define that as maximum now. Okay. So I'm going to say print maximum 2 and 3. I'm going to hit enter. That's what you get. Now, if I call on this maximum on its own with the two arguments, you get 3, right? Well, why do you get 3? 2 greater than 3? False. 2 equals 3? False. Return y, which is 3. So that's why we're getting 3 back. But you could do something like this if you needed it. Like, say if this is for people, total people, equals, we'll just say maximum. Got to spell it right? Maximum, we'll go say 2 comma 3 again. Nothing's returned, but nothing's returned to the screen. But what's returned from the function is stored in total people. So when I call on total people, it has the value that was returned from the function. So then, if you wanted to use total people somewhere else, you could use it in another function as another parameter or another argument, or you could use it in a print statement. You could store your data that's returned from the function and use it somewhere else. Super cool, right? When you're designing stuff, usually when I design stuff, I use path. Basically, if you call on this function, it won't perform anything. It simply passes the function. So we got a question in chat. So when you assign a value or a return value of a function, all the print output of that function is ignored or tossed into the void or something. No. So you could say right here, let's take maximum again. We'll take this right here. We'll return the numbers are equal, and you could design this a couple different ways. So we'll say the numbers are equal, and we'll return. Now check this out. We'll return X, and we'll return Y. Right? And we're going to make sure that we run maximum this time, 3, 3. So now we get a list returned back to us. We get the numbers are equal, X and Y. You could do something cool like this. You could do A, B, C equals maximum 3, 3. And now when we call on B, it's 3, C is 3, and A is our value. You could do some pretty cool stuff. It all depends on how you design your return statement. Well, what if I only had one value here instead of the 3 that it gives back? What do you think would happen? What if I just did this? And I used a variable called Z. Well, now Z is the list that return. Just do the last two and make it, it returns the list. So super cool. Is it a list or a tuple? It returns a tuple unless you tell it otherwise. And we'll learn about tuples next week, next lesson, more in detail. A tuple is basically a list that is immutable. So it operates very similar to a list, has indices. The numbers are equal as an indices 0. So if I call on Z and I call on 0, I'll get the item in the first item, which 0 is the first item. So it operates just like a list, except it's immutable. That means it's more difficult to change. A list object has things like remove, append. Tuple are designed to just be what they are. It's a safer object, usually returned by a database or something in transit, so it doesn't get malformed or altered in transit, things like that. But it's pretty cool, right? But that's next week's lesson, part of it. But now you know what they are, no problem, use them. It's not going to hurt you, right? So pass does just that, nothing. I use it when I do things like this. I'll just pull over a new file. Let's design something really cool. I know I'm going to have define a main function. I don't know what I'm going to do with it yet, so I'm just going to pass it. Then I'll define game, and I'll do a print statement or something. I'll get some input from people. It's like used to when you design something. Maybe I don't like that. Maybe I'll have my main, and this is fine. You can have your main function call on game and print test. And then down here you have play again. Man, I'm all over the place today. And here you haven't defined it yet, but you can hit pass. And then down here you can hit play again. Or you know what? You can have game call on play again. but nothing's going to happen because it's not going to do anything. Now, just walk into the next intro, like what's going to happen here? If I save this, test one, that's fine. If I save it as test one and run it, hit F5, nothing happens. Well, we defined all the functions, but we never called on any of them. That's a big deal. We defined main, it calls on game, but we never call on main. So what you want to do here is if name is equal to main, then run my main function. Now, this will go into memory, this will go into memory, this will go into memory. This will do a validation check to see if the double underscore name value under the hood in Python is equal to the double underscore name value in memory, which is the name of your script in the top left corner, if it's available inside of Python and there's no collisions under the hood. If this equals that space, it will then run your main function, which then main will call on game and execute game. But this will already be defined in memory. So this call pulls it from memory. It doesn't go back up in your script and run this. It doesn't do that. It pulls it from memory. And now we get test printed because this was true. It ran main ran game, game printed test, play again said pass, and that's how it operated.
Pretty cool. Well, you can also do this. Well, what if I
wanted to define this first? It still operates the same. Called in memory, or stored in memory, defined in memory, defined in memory. Validation check is good. Then it calls on main, pulls it from memory. Since they're all defined in memory, you don't get any errors. Now, what if after this, I define something called Steve? It will say I'm Steve, right? Well, test. Now, Steve is in memory. He just never ran. We never called on him. We defined him. He's stuck in memory. We never called on him. Well, what if I call on Steve in main? What do you think is going to happen? Any ideas? Anybody? Think about it. Defined in memory. Defined in memory. Defined in memory. Validation check. Execution. Defined in memory. Main's going to run before we define Steve. Main calls on Steve. We should get an error message saying Steve's not defined. And that's exactly what happens. It literally says Steve is not defined. Now it says on line 6, which is right here. See that line number right there? Line 6. And it's caused by line 18, which is right here. So line 18 called on main, which tossed an error for line 6 because it wasn't even in memory yet. Well, if we moved Steve to anywhere above when we call on main, and now it runs just fine. Order of operations and flow control matters, but the flow is a little bit distorted because I could even define Steve above main. Oh man, what'd I do? There we go. So I could define Steve above main, but as long as I don't call on him before he's defined, we're fine. Runs like a boss. So with the entrance of functions and the ability to create functions within your code, the distortion of how the flow of your script may change. And within your function, any logic you learned up until now, everything about loops and if and else statements and everything, you could use in a function. It's fine. That's what they're designed to do. The wild thing here is if I save this as test one, I could import main or play again into another script by literally using from test one, import play again. And then I'll be able to call on play again from another file as long as it's in the same directory. So what do I mean by that? Let's try it. File, new file. I'll call this test two. I'll just slide this over here. File, save as. Make sure it's in the same directory as test one. I'll just call it test two. And I'll say from test1.py import, we'll say Steve. And then I'll run Steve. Now, if I save this and run this script, it should print to the screen, I am Steve, right? Oh, what happened? No module name test one. Test one is not a package. Okay. So, let's see if I could do this. There we go. So that was my fault with syntax. I said from test one, import Steve and run Steve. And there you go. I didn't have to rewrite the function. I just imported it. So write once, use over and over again. What else works like this? What else works from one file, calling on another file to import a function and run? What works like this? Anybody know? It's okay if you don't, I'm here, but I'm curious if anybody knows. Any ideas? All right, I'll give you an example. The operating system you're running on does the same thing. So all Python files in Python are called modules. Py, pym, they're all called modules. And in your Windows operating system, under System 32, you got a bunch of these files .dll. They're dynamic link libraries. They're nothing more than millions of functions in these libraries, in library files, DLL files. You'll see malware and all kinds of stuff wants to screw with these files. It's fun, right? It's funny. But they're protected files, usually only ran by system X, Y, and Z. But these dynamic link library files are all these. There's tens of thousands of them, right? All DLLs all over the place. They have functions that do something that are constantly being ran to create the operating system you're running on right now. The window size, the scalability, using voice, video, your taskbar, where your icons are. All these little libraries run functions to operate your operating system. There's no difference. Well, they're very similar in the way that you can call on them to get things done. So if you knew C or some fun stuff or some PowerShell trickery, you can call on things that are already written on in your operating system to perform things for you in Python without ever having to rewrite them. Kind of cool, right? As you can see, these two files are both in the same directory under new. From test one, test two looked in the same directory it's in, found a test one, opened it up, and imported Steve for me. So when I called on it, I could run it. That is the power of functions. Yes, they make your script really easy to use and really readable and nice blocks and that you could define and adjust and call on. But you could save them for a rainy day and have another script call on it from wherever. And if you knew the absolute path, you could put in the absolute path here. So if they were in different paths, you'd have to use the entire full absolute path to import them. Now, let me stress one thing. I do not have your file paths. So if you decide to get tricky and use a bunch of different PY files to create a program or to complete a script in this class, I do not have your file paths, so it will not work. So keep your scripts flat, same one file. It'll be cool. Lesson 7 will mess with that a little bit. But I wanted to show you the reason why functions are super important and what I mean by write once and use over and over again. Because now I have another program, test2, calling on test1 to run Steve, even though I never loaded test1 in memory. Test2 did it. Pretty cool. Everybody get that? And when I talk about mainline logic, this right here, that's what I mean about mainline logic. Every script you ever write should have a main function. It's good practice. Can this be any name? Can that be any name and this any name? Yes, but it's good practice to have a main function that performs your main duties. Good practice, good practice, good practice. And it makes it easier for all of us to know how your code operates for those who have to read it. So it's good form. Read Pep 8, and it'll tell you all about it, right? Let's see what else we got here. We already beat it up with the parameters and arguments. Blah, 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 blah. Break it down. Yeah, that's good. I feel pretty good. I feel like we kind of covered functions in their basic use, right? Any questions so far? Could be about anything. No, nothing. Nobody's got any chat or anything. Is it cool? All right, let me check out the group lab then. That's it. The group lab. There's a couple of them, right? The group lab will make some sense. We'll have some fun with it. Boop, boop. Here we go. So the group lab got a couple. We got write a program that simulates rolling some dice. That's cool. So to add it up, and then we have a math one. Generate some random numbers. Import random. We'll talk about that. Well, we can do that right now. So within Python, there's modules. A lot of them. Import random. Random. If you do a dir on the module you import, you will see, you got to spell it right though. This is the important thing, got to spell it right. You will see all the functions and methods inside of that one module. You see that within the random module, there's tons of stuff. All these double underscore, single underscore. Did you get into these fun things? Choice, random choices. Those are some pretty good ones to use. Random int, random in general. These are in shuffle. These are probably the top 5 that you'd use in this course. I'd say choices, random, and shuffle. Those are the ones that are probably the best. Sample, you could use random range is cool if you needed to develop a random range for something. But we'll talk about a couple of these. So anything random does. Random works a lot like, yeah, random number. Yeah, within constraints. You're right, Joe, right? So if we just call on random, now if we call them random, well, we want a random integer, right? So we call in the module name, dot notation, the method of random integer, and we say we want a random integer, and it kind of prompts you. It takes 2 arguments here. We'll start at 10, and we'll stop at 101. And it gives me a random integer of 36, which is between 10 and 101. Cool. You can store that in a variable. If you change this to 5,000, give you a random integer, so on and so forth. Rand int works pretty good. But when you just say import random in a script, it imports the capability of the entire library. Not much of a problem nowadays, but you can fill up your memory pretty quick if you do a bunch of imports. So let's write a new file here. And let's get busy on this dice one. I'll let you folks mess with the math one on your own, right? So you're going to have your template, your header. We're going to go ahead. Let me grab this. We're going to do the dice, right? First thing we're going to do, good practice, is import the modules so they're available globally to everything in your script. Now, I could write import random, and like I stated, that'll import the entire module. I only want to use one function of import random, so I'm going to say from, and now I state the module's name from random, import, and then I'll tell it just the method or the function, random integer. Then I'm going to hit enter. It'll only import random integer, but you don't have to type random.random integer. Python does it for you. So all you have to do is type randint now and it'll work. And we'll do that. We'll do randint, and we'll say 3 to 500 just for fun. And we'll say print this, right? Save. I'll save it as test3, even though it's group lab. And now there's my random integer 199. Now you could also say from random import randint and then follow it with as and just RI. So now you can give it an alias that's shorter, RI, random integer, save it, F5, 474. This right here, there's some ones like pandas and numpy that when people import pandas, it's usually PD, and when people import numpy, it's usually NP. So there's rules of thumb when you import certain things, like so other people know what they are when they read your code, but basically tells you up top from random import randint as randint RI. So shortens your typing a little bit. Pretty cool, right? So now we have our function of randint or the method of the module randint available to us. Cool. We got to roll some dice. Well, I'm going to define my main function. I'm going to hit colon. And right now I'm just going to say pass because I don't know what my main function is going to do yet, right? But I know I have to define roll dice. And I could take some arguments here, or I could ask for some input. In this case, I'll just define my function of roll dice, and we'll say one die, but we're going to pretend like there's two. So there's a trick we could do here. We could say for each roll in range with the length of one, stop at one, right? So it's just one roll. You could do die one equals, and here we call our random integer, and we're going to do a six-sided die. So this isn't like range though. It actually stops on what you tell it, not before. That's one thing I want to point out. So it's not like this was stopping at 500, which 499. It literally stops at 500. It's part of the set of numbers you choose. So if we're doing a six-sided die, it'd be 1 through 6. Cool. Well, the cool thing about the die is I could have multiple. So now I could say my second die. So now I got two random rolls, one stuck in die 1 and die 2, and then I could call it a total, which equals die 1 plus die 2. And then I could print, we'll use the F statement here. Let's see, you rolled we'll call on die 1, and we'll just go die2 for a total of total, right? And we'll see if this works. Well, what would happen right now if I ran this? Anybody know? I'm gonna hit F5. Nothing. I defined everything, never called on anything yet. Well, let's change this. Let's say, and you could just design this a bunch of different ways. Three different ways come to mind off the rip. Gotta do our if name. Some people argue that this isn't needed anymore, but it's best practice. Is equal to main. So if something goes wrong in your file loading project, or if it gets bumped out of memory or something, this wouldn't work and it would save you from wrecking a server or wrecking a program, right? There's a lot of reasons to perform this. So now we're going to do our validation check. We're going to run main. Main is going to call and roll dice. Roll dice is going to generate two random integers, add them together, and then print something out for us. Save, F5. You rolled a 2 and a 2 for a total of 4. Cool. It's working as designed. Well, what if you want to play again? Well, there's a couple different things you could do, right? Well, let's just play again. Let's define another function called play again. Gotta spell it right. You don't really have to, you just gotta make sure it's spelled the same throughout. So we're gonna define play again. And we're gonna say PL again equals, now we're gonna gather some input, right? From the user, input. Would you like to roll again? Or simple, roll again, question mark. And give them the opportunity to answer with a yes or no. And give them a tab with a colon, right? So they're going to input a capital Y or capital N. We'll leave it at that. We could change it to lower. We may in a minute. So now we have if PL again is equal to Y, then we call on main. Because main will roll dice. Now, this is one way to design this, right? Else, you can print, thanks for playing. Okay, so we designed play again, but where do we want to put it? Placement matters. And our design choice to make it a separate function allows us to use this play again function somewhere else. And we could simply say play again, and now it could turn into any game. So maybe I'll do that. Play again. I like that. Makes this reusable in other code. I could grab this and put that right there. So in theory, what would happen? This would be imported. This would be defined. This would be defined. This would be defined. We'd call on main. Main would call on roll dice. Roll dice would generate two random integers, display them with the total, and then prompt us again to play again. And depending on how we answered play again with yes or no, it'll fire main or hit thanks for playing. All right. It's a good, solid design. One way to do it. I'm going to say no. Oh, that's me. That's what was in my, there you go. So I hit no, thanks for playing. Okay, that worked as designed. Let's run it again. I'm going to answer it yes this time. Oh, what happened there? Why didn't it work? Any ideas? Let's close it and rerun it. It's my fault. Look at the baby Y. I said capital. The baby Y broke it, right? So let's do that again. Thanks for playing. Now, a way to fix that, dot lower, changes it to lower. Now we're good to go. Now you could have added an or statement here. Play again equals lowercase y, or play again equals capital Y. One of those would be true, right? But now I just hit lower. So no matter, even I could leave my directions as caps. It still grabs the user attention and forces them to put a Y or an N. And there it rolled again. Turned it to lower, Y equals Y. But you see I'm in a loop, which I wanted. Every time we play, it's going to ask us to play again. And I could simply answer no. Thanks for playing. Good job, Joe. Are we satisfied? I mean, I would define some type of welcome, and you could put like print statement. Gotta spell it right too. Welcome to the game. I'm just gonna do something very generic, but you want to do something guiding the user. Well, this is cool, but let's take a parameter. Let's take an X. All right, let's change this to an F statement, and we'll call on welcome to the game. Well, there's X, but how do I get X? Well, you could define gather name, and you could put name equals input enter your name, and then you could return name. Now, instead of this happening, right, so we have our gather name function, which is going to gather the input in the name and return name. And we have our welcome function, which takes X and then prints the welcome with their name. Can you, under main, before roll dice, call on welcome, which then calls on gather name. Will that work? Sure as heck does. So now, not only can you create a function to gather input from a user and return that, but you could use that function as another argument to feed another function to take the place of a variable. In this case, it's Tim. That's another super powerful tool from functions. And can you write functions with sub functions underneath it too? Yes, usually not necessary at our level. Nested functions are just like nested if statements. They get kind of sloppy really quick. And there's something called a lambda, which we'll talk about in lesson 7 and 8, that'll clean up the need for most nested functions. But what do you think for today's lesson? What do you think of reusable code? Any comments, questions? It's a lot to take in an hour. Think about what we covered. No, sweet. We learned how to define a function, how to pass a function parameters, when they're parameters, when they're arguments, right? We learned how to return a value from a function, store that in a variable, and use it as another argument inside another function. We also learned how to import certain functions from modules. And we also learned how to have functions call on other functions to perform a task, as well as mainline logic. We learned a lot. There's a lot more you can do with functions. We covered about 8 or 9 things you can do with them right now. Insanely powerful. Now, if you write yourself a really good Lesson04 script, which is what? Let's take a look. The individual lab, rock, paper, scissors. If you write a really good, well-designed rock, paper, scissors, your final will be easy because you could reutilize your code from this lab. Write a nice welcome. Write a nice function to gather input. Write a nice function to perform that input or perform whatever the script is necessary to meet the requirements. Nest it all under main. You have a pretty good template now to reuse for the rest of the course. Now, for the people who don't watch this video and who aren't here, they're not going to know that. And that's a shame because the whole concept of this course is to make scripting more fun, easy, and quick. When you write yourself a good template with good starter functions, most of your job is already done. It's just gathering the data for the variables and then whatever math or logic you have to perform on those objects. When you're scripting as a cybersecurity specialist and say you want to gather the files in a location, you can read this. Now, I named all my variables what they are. That's number one. I didn't use X or Y or Z, right? I simply defined a function called getFileList. I defined a default parameter with the value of the location. Now, could I have done something like our other command and ask for input there? Yes, you could. Enter the directory you'd like to enter, right? But I literally gave it a default value of my C users, Z Whiten desktop. I created an empty list. Now, OS is an entire module. Let's talk about that. Where's my output for this? I think I closed it. No big deal. I'll just run this. I'll actually run this. Boop. So squeeze text 235 lines. If I double click it, it returns me a list of every object that's on my desktop. And it's full path, right? Could be handy in cybersecurity land. You could do a find in here looking for a specific file type. You could look for an extension. You could do all kinds of things. I just dumped the entire list. No big deal. Now, from this, if you import OS, if you do a dir on OS, you see everything that this module has to offer. System, sys, terminal size, times, remove directory, read, open, a lot of things to work with the operating system. Kill processes, make directories, some normal commands that you'd find in the Windows terminal, except with mildly different names. Some of them are identical, some of them are different. Pretty cool, right? So you can interact with your operating system from Python. Sweet. You can interact with the system too, which is different from the OS. But let's just get back to the script. This simply dumps the directory list of my starting directory. And it says for each object in my list of objects, or for each file in my list of file names, OS path join the starting directory, this, plus the file name it found. So now I get the full absolute path. This is the full absolute path right here. That's what I was talking about. So this creates the full absolute path for me. And then I check if OS path is a directory. This gives me back a Boolean true or false. Is the file name a directory? True or false? If it is a directory, it's going to break it apart and look inside that file name. So it's going to almost do not really a recursive check, but a recursive check. Right? So right here's a good example where it went into work, desktop work, and went into PyCache and went to that file. So it did a recursive check. And then if this is false, if this is not a directory, it just prints the file name, which should be shorter. right? Which is stop at desktop, which is more up here, like right here. See user's desktop, and then I have that on my desktop. Then I return the final list, which is everything. And then I store that list. I call on my function. Well, I do my imports to find my function. I call on my function to run it. I store the list, the output that I return in ML, and then I print ML, and that's why you see it over here. Now, can you also do things like this? If I said how many items are in my list, you could then do length of my list, save it, run it again, and now it'll squeeze all the lines, but I have 279 items on my desktop recursively. Cool. Pretty handy, pretty helpful. And lesson 5, we'll learn more about if, find, and in, and then you can search that list for certain items. Kind of like build yourself a grep almost, or a find. But this is pretty handy, pretty dandy, pretty cool, right? I'll dump that in chat. You can tear it apart. And there's a bunch of different ways to build it, of course, and that's just one way. But that's the whole beauty of functions, right? You can cut and paste this, go, oh man, I really need to do this time, and alter it just a little bit. But the basic logic is already done for you. Just need to change a little bit. Rename it version 2 or V2 or whatever, give it another parameter, argument, change this to an input. You could do so many things. You're limited by your imagination. And test yourself, have fun. I'm probably going to see 10 of the same rock, paper, scissors scripts, and I'm going to know the site you got them off of or how you asked ChatGPT, how you prompted it to get it. And you're not helping yourself by not learning how to code. If you actually learn how to do this from scratch, like we just did with the game, right? Wherever I closed it, what it'll give you is the ability to think critically, which is the whole purpose of this class. And the minute that you can think more critically about how you want to design something, then you could use generative AI to help you even fine tune your code, make it more optimal, or ask it the next level, because this is like basic fundamentals of Python. There's an intermediate, and then you'll never be a master. It keeps going on forever, but you could beat yourself up pretty good. I did for a while, and you can have a blast with it. But get a hold of it. Design some code. Call your variables and functions what they are and what they do. I advise highly not to name a function and a variable the same name. What I used to do in the beginning when I was not thinking clearly or I was designing quickly, I'd put a small f in front of all my functions. Just in case if I named a variable welcome, I know that my f welcome is my function. That's one way of doing it. Or one way of doing it is just not to do it, right? Just don't reuse the name. And you see, I did that right here with play again, and I just said PL again. A couple different ways. But we covered a lot about functions. And there's a lot more, but this is the fundamentals. This is where you need to be to be successful in rock, paper, scissors. Any questions about the individual lab? How many different outcomes are there for rock, paper, scissors? What if I didn't want to play? What if you came up to me in real life and said, "Hey, you want to play rock, paper, scissors?" I'm like, "Nope, I just don't want to." So that's an option. You can code that. Do you want to play? Yes or no? What if halfway through the game I want to forfeit? I don't want to guess. Can you enter Q for quit? Maybe. That might be an option. Or F for forfeit, right? And let's talk about design. Rock, paper, scissors. Can I do rock equals 0, paper equals 1, scissors equals 10, and then do math on the back end to see who wins? As edge cases. Yeah, you're right. Now, you could do a match statement, a case statement, a switch statement, all these more complex things. Don't. Prove to me that you know these fundamentals of simply designing something with your mind and using the tools that you know of. Some of you are going to turn in a case statement or a switch statement, and that's way out of scope of class. You're not going to know what it is. But I know ChatGPT or some generative AI is going to give that to you. And it's not in the fundamentals of Python because it's not a fundamental. It is an intermediate level. If you use something not in the book, you best comment it, or I will take off points, or won't even grade it, and I'll ask you a question that you won't answer, and you'll get a 0. We've got a bunch of those already. Some of you are using very complex data types for one of your scripts. A couple people used a dictionary, a very complex dictionary last week, and then the other script, they didn't use any. And if you use a dictionary in one script, it makes sense to use it in both, but it was just weird. You could see that they changed their prompts or did something different. It was pretty funny, but and they never did answer me what a dictionary is. So that's sad times. But don't worry, that's literally how can answer. What do you mean? I've been saying from the beginning, and you didn't read the announcements then. The announcements say if you use a complex object type or any complex thing that we don't talk about up to that point, you better put a comment after it and tell me how it works. That's exactly how you answer. And in my emails to you stating that, you can respond to the email. You can put a comment there. You can comment it. I can comment right here if I want to. If this was something complex, I learned this in a Udemy course or something. Tell me how it operates. Tell me what a dictionary is. Tell me the breakdown of it. A lot of people are using complex stuff, and my theory, and well, first off, a lot of people are turning the same script, point blank. Well, a space isn't a digit. And is digit only works on what? Integers and floats. That's where it'll give you a Boolean true or false, right? Unless you wrap it in quotes, because that's a string. Yeah, and you see, already starting to use validation. Like I'm picking up what you're laying down. Use validation. I already explained it. I pick up what you're laying down, but just keep in mind, I got 60 students, right? I grade 60 different scripts, and 11 of them are the same on the average. So I already know that we have a pool of people who can't use generative AI correctly, or Google, or go to the same website that first pops up. And if you can explain it, explain it. I'm just saying, if you use something that we didn't cover yet, I'm going to question it because that's my job, right? I'm literally your instructor. I'm going to go, hey, I didn't show you that. How do you know that? And you're going to tell me, I'm like, cool, right? It's okay. We pick up different things from different places. Learning isn't linear, but I'll tell you, out of 7 years of teaching scripting or programming, most people come into a fundamentals course without any idea what they're getting into. Now, there's that prereq of logic. That doesn't covers very menial Python, and it I wish they wouldn't have it as a prereq because it actually causes more damage because students come to this class thinking they think they know something. And they know of the terminal, they feel comfortable with it, but they really don't know what it's doing under the hood. And that's the issues I have with the prereq of logic. But this is an 8-week course. I do teach a 12-week and a 16-week. Can I speak? Yeah, I can speak. Where are you? I'm waiting. Unmute. You should be able to unmute. You're unmuted. Talking? Anybody hear him? Nope. Yeah, same here. I'm gonna go ahead and stop the recording. We covered everything. We covered what? We covered the game, this fun thing. I'll put this in chat too, so everybody has it. And it's one of many ways you could solve this, right? And you still have there's one other group exercise and the individual lab. Remember, if you write a good lab this lesson, it'll help you out for the rest of the course.